Okay, why? There you go. I don't know why the laptop is going nuts, but it's hard. It's hard. It's hard to kind of keep working at it with such breaks, but it's all I can do. I have to live with this, and let's just get going. So what were we doing? We're doing basically. What do we have here? So uncertain systems roadmap, and we were stuck with the exercise with the polar coordinates, and we yeah. So we want to do this stuff here. So and kind of like, what was the rewriting? So this was the solution, and so we're gonna do volume integrals rewrite. I think there's the in triple integrals. That doesn't help me. Tricks. So that is the tricky. The tricky is going to be this rewriting. So what is this person say? So I was wondering if anyone can share some tricks in systematic way of rewriting a triple integral. It's an exercise I'm doing. Trying to rewrite these two dy, dx, dz. I have drawn the picture out and realized it's sort of a half cylinder being sliced by the plane. Correct me if I'm wrong with the description. So it's a systematic way to change our quantization without integrals, but you can write all the limits as inequalities and then deduce the new bounds from them in order for order from outside to inside. Again, what are we doing here? So what are we doing here? So shell basically Python x to the 1a. What are we doing? So I've done these. Why am I just... What am I doing? Is this really the latest stuff that I did? So let me check in here. No, here.
We're alive, finally.
So this is the one that I did last time. Where did I finish?
Right. Like, it has two dimensions. Time is zero, so we're ignoring time. So it's a function of just x. So yeah, you see, but that's what's bothering me here. But there's a value involved. Like if you just give me r, I'll give you a value, right? Yeah, you see, but that's function of. So time is zero, so we're ignoring time. So it's a function of just x. So in this case, the way of expressing that isn't that you're just 2 pi, right? Because it's the full three-dimensional space. And so it really just, the values just depend on our.
So I'm sure that this is three-dimensional space, as we said. I just had a bit of a lapse when it comes to, where's my pen? Just had a bit of a lapse when it comes to man, I can't find the pen. Who the fuck stole my pen? Ugh. Really? There's no pen? God. Anyway, this is like, so this is like basically so plot so exponential of like minus you know, minus say 1 times and then x, right? And so that's this here. Yeah. Minus 2. You know. So this is basically this alpha, and then if I say here like 3 times something, whatever it is, but yeah. So this is just is that kind of exponential like these? Okay. But then x cannot be x can only be positive. What am I doing? So I do basically e to the power of minus you know, 1 times and then x, right? Oh, times x. No, I want the oh, there you go. Why was Google, why is that bad? What's going on here? I don't understand. Why is this being plotted like these? Anyway, this is what we want to do, and so so we know, so in a way I know that from one, but if I imagine that in 3D, it's going to be like a kind of cone. It's like some kind of cone like these, right? Not cone, but like, yeah, something like these. And then so on one end I want like 360 degrees, and on one end I just want like 180 degrees, because I know it's never going to be down there, right? Because we know x is always going to be positive. Yeah. You know, and even if this is like that, then it's just the other side, exactly. So if alpha is negative, exactly. So I'm pretty much convinced that this is going to be like that. So if I'm assuming, I'm just gonna try to understand that too much up front, but I'm gonna assume that somehow, you know, the boundaries. So we've got like definitely boundaries. On one end is like from 0 to 2 pi. And on the other end is from 0 to pi. Yeah. And this guy here, to be honest, oh, and this is where alpha goes, I think, isn't it? Let me see. No. At least 5, 6, no. But it's always 1, is it? Why is it always 1? Yeah, it's always 1, of course, because e to the power 0. So 0 to 1. Okay, 0 to 1. So 0 to 1. 0 to 1 is sort of the z. So this is the z-axis. This would be the, what do we do? What do we do? So what do we do? We do what's the convention? Z-axis, I think, x and y. So the x is going to be, this is going to be x, and this is going to be the y-axis. I don't know. This is my working assumption, and so how do I rewrite these? Well, I have to rewrite. So I do have to rewrite the r. Do I just have to rewrite and say that like r is do I have to just rewrite and say so 3D radius formula, or is it just or length formula? Is just this exactly. So it's square root of like pom 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 squared. So do I just have to say it's basically square root of you know, x squared plus y squared plus z squared? We just draw. Is this what the function is saying? So this is the function that I have. And now I wanna rewrite it so I can do things like these, right? In polar coordinates, do I have to rewrite anything? Yes, because I have to transform these x and y's and shits like this with cosines and crabs, right? Because essentially what we have is the following. So we have so we know r. And then we have z, and we have one component and one component. So this z is fine. R we know. Or z is fine. Fuck r. But then we have, so if this is y and this is x, right? So this is where the two angles come into consideration, correct? It's just like sinus or cosinus or some shit like this, I guess. So rewrite so not polar. Cylindrical coordinates. I just need a formula. Khan Academy. Triple integrals. So the volume. What? There's no. So they include the R. As expanded as R d theta dr dz. Oh, okay. So you only need the one angle? Radians, yeah. Volume of a sphere. This is the radius. Okay. Well, we're missing something, aren't we? I mean, this is definitely these, is it? Correct. So since the bounds of z will depend on the value of r, we'll let the innermost integral handle z, while the outer two integrals take care of r and theta. So integral. Okay, so are we doing this correctly? So of a unit sphere. Okay, so you don't. Oh, this is 3 blue and brown. Is it just a rotation? Okay. Using polar coordinates. Okay, so maybe in our case it is already, I mean, we already have it in polar coordinates, so there's no need to there's no really need to rewrite anything. We already have it in polar coordinates. So then it's just these. So it's r dz dr d theta. So the main thing to remember about triple integrals is in cylindrical coordinates is that dv represents a tiny bit of volume expanded like that. So using cylindrical coordinates can create similar triple integral. It has some kind of rotational symmetry about the z-axis. That's exactly what we want. So we wanna do these. Okay, but they're always. Ah man, I feel I'm at one like little very almost there. almost there. It doesn't matter in which order I do them because Python does them for me. So that's fine. So we have R, but what we want to do is I just don't get how that actually works at all with just specifying one angle, or how does it work at all if the function is like these. You know, there's no d theta, right? So how is that even solved? That's interesting. I mean, the sphere is just the radius, right? So if you tell it the radius is just the radius, that's an interesting example. So of radius 1. First of all, make sure so it's just 1. The function is just 1. This is hard part of putting bounds in integral. That I understand. But how is the step by step? Since the bounds of z will depend on the value of r, we'll let the innermost integral handle z, while the outer two integrals take care of r and theta. Writing down what we have so far. Okay, so I mean I have the bounds. It's important to make sure the order of the differential terms is that and matches up with the appropriate integral. The next one is a little trickier. It feels it's like yet another failed video. Failed session. A theoretical function inside the sphere. Our computer will change. Okay, so the three variable function. This might seem out of place in the article about integrating in cylindrical coordinates, since everything there is in Cartesian coordinates. Indeed, you can triple integrate in Cartesian coordinates if you want it. However, in polar coordinates this becomes very simple. The angle is pi fourth and the radius is 0 and 2 always. So, what did I say? It's wrong. Z is, I mean the radius is like between 0 and infinite, right? But we know the bounds on Z is 0 and 1. So putting this together, our triple integral looks like this. 0 and 1, 0, 2, y 0, 2, the radius, oh, so they're actually steps by step by step. So how do they do these? First they do Z. Cool. Then this is done. Then they do R. Oh, so here's when you get the theta angle. You get it because of at some point because it's got to appear in your boundaries. In this case. The bounds of that can be translated to this theta. I mean, in a way, maybe this is what I'm missing. No, I mean, I know the bounds of, so I know it's cylindrical. So I know I want to do 2 pi in my case. In my case, it's like these, right? So it's like these, and it's like symmetrical. So almost there. I just have to find. The right. Maybe it's just easy. It should be easy because it's just. I just got alpha. This is just a parameter, so that's fine. It's constant. It just got R. It just has R. It just has R in it, right? So it's a bit like the sphere example in a way. It's just got R. My function, it's just that one. So maybe I just have to express these things so as function of R in a way. That's what I'm not really processing at the moment. 0 to 2 pi. This is the same. R radius 0 to infinity. and z, how should I express z? Z is just 0, 1. Am I just being an idiot? Am I just like am I just being too stupid and I'm just saying, well, like just do the triple integral and that's it. Don't necessarily have to. I mean, am I sure that z can be bigger than 1? No, because it would mean negative radius in here, right? Unless if you give it a negative alpha, it's not only that, so it's like no, the radius can be. So what is the radius? Am I being confused? I'm being confused. It's just a radius, right? X is the radius, so X is the but he is plotting it and again I kind of I'm clashing again with the same concept with the dimensions and whatnot in my head, because I'm confusing myself because I'm plotting it against x, and I'm talking about the radius and whatnot, and I'm just saying that is how something would look like. But we know that x can only be positive, so we know this is a limit. X can be positive. That's it. That's all it can be, right? But alpha can be negative, so then it means it can also be like that. Yeah. I'm not so sure if that's the volume that I'm thinking about. But it could well be. Anyway, have to. This is a super hard problem without any guidance. I mean, I have the answer. I'm just really lost in terms of what is it that how do I even start? Like I know I have to start with something. I know I have to. So I know this is the function that is just depends on r, right? So but again, I'm kind of circling around the same issue of like, is it then my function 4-dimensional or 3-dimensional, right? Because it's like for 3-dimension space, what the function is telling you is, in a way, sort of the probability that it's there, right? Because remember, I have to do it square. So I have that function squared, and it's telling me the probability that it's there, and I have to. So in a way, this is 4-dimensional. That's what's bothering me a lot. You know what I mean? Like, unless I would say, unless I would, do something like I just do the one-dimensional integral of these, and then somehow sort of apply then that rotation, right? So times the 2 pi, which would kind of tell me why the pi is here. So that's kind of my main problem, is that we have here's more like of a 4-dimensional thing, right? So if I try to go on like when I do exercises, I'm like, okay, so let's just assume x is 1-dimensional, right? So it's just your wave function actually is 2-dimensional, right? So and that's what you're then calculating the area of. And so in this case, if x is in 3D space, then we're talking about a 4-dimensional function, which then all this gibberish that I'm doing does not really apply here. Whereas now if I just go and say, this is my function, please integrate it like this, right? What do I have? So I have basically what I have here. So I have, if I say n is going to be, I don't know if n is going to be positive, but like a is definitely non-zero and r is positive. So if I run these, what does it tell me? It tells me that I have n squared divided by 2 alpha, okay? But again, this is just a slice of it, right? This is just a slice that I have to somehow still I've just integrated across like r, so this is just one slice, but I still have to apply some sort of, how that 2 pi rotation to this, I don't know. It almost feels like this, because then I have like so if I have n squared and then 2 alpha, and then I do this 2 pi, then I basically, the 2's cancel out, and I have like n squared is basically pi divided by alpha, which if I then kind of do these, it tells me that n equals like pi divided by alpha, like that, and the solution is really close to these. It's alpha divided by pi. Fuck. Oh no, but that's kind of makes sense. What am I doing? No. So n squared divided by 2 alpha, and I'm adding 2 pi. And so if I wanna say that and I want and I think I want this equaling to 1, so it's alpha divided by pi. That's correct. The 2's goes and it's alpha divided by pi, so it's n. So it's this, and it's alpha divided by pi. That's correct, that's fine, but I have here, and the answer, it's alpha to the power 3, and then this is actually, it's almost like these repeated 3 times. I don't know why, but it's really similar. So I'm like, I don't feel like I'm that far away from the answer. I really don't feel I'm far away from the answer, but I just don't know what the answer is. Because it doesn't seem like this is something that I need to do necessarily. This whole like, I don't know. Next time, I feel I'm almost there. I'm just missing a 3 here and a 3 here. almost there. Because yeah, I can't imagine it in 4D, but I can imagine it in 3D. Why wouldn't this work like that? You have a sphere, and then you just say like, look, I'm gonna do just that, and then rotate it 2 pi. Like, why can't I just integrate a slice, a 2D slice, and multiply by 2 pi if it's a pure sphere? Why can't I do that? It would seem intuitive, but maybe there's just something wrong in there. Anyway, see you next time.